Graphically. So we are going to be using a graph to interpret direct proportion. Now if you can remember, direct proportion means that on a graph like this, it starts right here. These are directly proportional. So let's use this graph to interpret. Now if we have a graph like this, where our revolutions is 1, so we go this way 1, and our distance is 2, so we go this way 2. So we go 1 and we go 2. It's right here. Another point is we go this way 2 and we go up 4. Another one is 3 and 6. So each time we're doing it. Now if you can see, 2 equals 1, 4 equals 2, 6 equals 3. We're putting them into proportions. Now all of them you could say are equal to 2, which is equal to each other. If we can say this, they are directly proportional when equal. Okay, they're directly proportional. Now, we could know that this is true by graphing it. So if we take these points, and the tops we have as y, and the bottoms we have as x's, and we turn this into a little chart, so to say, we can graph it. So now on a graph, kind of like the graph I just showed you, for every one that we go 1, 2, and 3, up we go 1, 2, and 3. So 1 goes up 2. I'm going to make each of these a line. 1 goes up 2, 2, 4, 2, right here. The line is straight. Oops. So the x-axis, you can see that we went over 1. Y-axis, you can see we went up 2. So that is x-axis, this is y-axis. Now these are directly proportional. Let's try to see based on a graph if it's directly proportional or not. Example 6 says, tell whether each graph represents a direct proportion. If so, find the constant of proportionality. Got an at. Alright. So A. You see this graph here? Oops. This one? Well, is it directly proportional? Yes. There are a couple of questions we can ask. So directly proportional. When equals. So number 1 question you want to ask is, are they equal? Yes. Number 2 question you want to ask is, does it begin at origin? Origin is right here. If it does, it's direct proportional. 3, straight line. Is it a straight line? Yes. So if it is all these things, then we could say it's equal. Now when you're just looking at a graph, we're going to answer these 2 questions. So if we're looking at a graph similar to the one in the book, is it a begin at the origin? Yes. So answer 2 and 3. Is it a straight line? Yes. So is it directly proportional? Yes. Directly proportional. Now let's find the constant of proportionality. Constant of proportionality, we can find a point that it passes through. So you're going to find the constant, you're going to pick a point. Like, for example, I will pick the point on this graph, 1 and 10, because it goes over to the 1 and up to the 10. So therefore, 1 and 10 is my point. Then you're going to put it into the formula, y over x. So here is going to equal 10, because this is y, over 1, because this is x. So it's going to equal to 10. And that is our constant. Okay? Let's do another one. B. First of all, is it directly proportional? Let's look at these questions again. Does it begin at the origin? No. So we don't even have to look at the other ones. No. Not directly proportional. So we don't need to find the constant. C. Is it directly proportional? Or does it begin at the origin? Yes. Is it a straight line? No. Therefore, no. It is not directly proportional. Try this on guided practice 1, 2, and 3. Okay, example 7. Interpret a graph of direct proportion. So we're going to learn to interpret it from like more of a story problem. It says Jonathan works at a bookstore. The amount of money he earns is directly proportional to the number of hours he works. The graph shows the amount of money, W, dollars, he earns in T hours. Find the constant of proportionality. How much does Jonathan earn per hour? So it gives you the graph already. Here's our graph. Now it says, find the constant of proportionality. How much does Jonathan earn per hour? That's 2 questions. So first let's find the A. Let's find the constant. Well, remember, constant is y over x. Well, in this problem, the y-axis is actually the wage earned, so it's dollars. And the x-axis is actually time, because that's how long it goes. So time in hours. So now we could make our new formula to say money over hours is our constant proportionality. So let's do our steps from up here. Step 1, pick a point. Alright, I'm going to pick the point 1 over 15. 1 and 15. This is x. This is y. So then step 2 from up here says y over x. Our formula is dollars per h. So which of these is dollars? Which of them is h? Well, y, remember we said was dollars. X we said was h. So 15 goes over the 1. And our constant of proportionality is going to be 15. Now we have to figure out how much spent per hour, or how much earned per hour. Well, the constant of proportionality is the answer to that. So if it's 15, we could say it's $15 per hour. Okay. B. Write a direct proportion equation. So if you remember our direct proportion equation, y equals kx. Well, here our direct proportion equation is going to have just different symbols. So we have our dollars, which is wage earned, h, which is time, and then k, which is our direct proportion here. So we could rewrite this as y, which is w for wage, equals k, which we know is 15, and x, which here is represented by h. See? If Jonathan works 4 hours, how much will he earn? Oh wait, C says, explain what the point 230 represents in the situation. So in our graph here, the point 230 means that at 2 hours, so 2 hours have passed, and he has made $30. Yes?
Okay, sorry to interrupt. I'll just stay for a while.
Okay, your name's on the board. Alright, so he has made in 2 hours, made $30. Alright, D. If Jonathan works 4 hours, how much will he earn? Well, let's look at the graph. 4 hours, 1, 2, 3, 4. If we find out where it meets with the line, it meets at 60. So we could say that he earns $60. E, if Jonathan wants to earn $45, how long should he work? Well, we trace a line from the $45, which is here, to the line. It meets up at 3 hours. So see, we could use our graph to solve this. You could also use the equation to solve it, but we do not have to do that. So there you go. Try guided practice 4, and that is all for today.